In Z operating system, it has some sort of set of related instruction, and this group of related instruction is called routine or modules, and a set of related modules that make a particular system possible is called uh, system component. A system component is a process, a program, or a utility, or another part of instruction within the operating system that help to manage different area of the computer. And one of the example here is the workload management. So we're going to discuss this workload management in uh, preceding slide. Uh, system program or system component, uh, we can technically uh, relate this specific program to the kernel of the uh, ZOS. And then ZOS also has some sort of a macros program that expand automatically into a set of instruction to perform a particular task. And it is a uh, capacity to load and execute the data and then sending to the uh, computer registry. And COS also has what we call program status word or PSW. It is a PSW is a register in the processor which include control information to determine the state of the CPU, and also it keep tracks on the current state of the system. As I said earlier, as I view to you the specs of the Z system. I'm going back to this Z system. As can you see, we have a 12 uh, pieces of physical processor, and this 12 physical processor each has a 5.2 gigahertz, and mostly combining a virtual core of 190 core. So can you imagine 190 core in a one computer system? So you need some sort of a program that monitor that, and that's the job of the PSW. So it is a some sort of code in a in some sort of register code in a processor, reside in the processor. Uh, it contained address of the next instruction that need to be processed. And as can you see here in the diagram, the middle part of the PSW is the register bank. This is where this code is reside in the processor. And the another rest of the code, you have the parity code for the error checking and user's flag of the information, and the overflow bits, so that the system can determine the next uh, code that series of this particular job or particular instruction. And then uh, the operating system is capable of multiple programming or executing many programs concurrently on behalf of many users at once. And in multiple programming, when a job cannot be use the processor, the system can suspend or interrupt the job uh, to free up some of the processor and work for the another job. And COS can also perform uh, multiprocessing, which is a simultaneous operation of two or more processors that share the various hardware resources. For example, as memory or external disk storage device. This process is commonly called a SMP or systematic multiprocessing. And COS has a control block. Control block serves as a vehicle for communication throughout the COS. Such communication is possible because the instruction of control block is known to the program that is used, and this program can find needed information about the unit of work or resources. The control block representing many units of the instruction or maybe same type of instruction may be chained together and queues, which each control block pointing to the next one in the chain. The COS operating system can search the queue through the addresses to find the information about particular unit of work resources. As instruction executed uh, for the work or for the instruction process, the COS keep track of this control process through the system-related control block, and then the each system block represent a system-wide informations that needed by the processor to process this particular job. No? Each processor in the mainframe computer uh, need to have a uh, registry address of those particular control block to be able to determine the flow of the instruction. ZOS manage three different kind of storage. The first is the real storage. Second is the auxiliary storage, and the third is the virtual storage. I'm going to discuss this one by one. Real storage is a physical storage located on the mainframe processor itself. No? This called processor storage or real storage or central storage because it is reside in the mainframe computer itself. As can we see the diagram here, no? The local storage wherein you install the COS is the what we call the real storage or physical storage. for the auxiliary storage is also a physical storage but external to the mainframe. Including to this storage are the HDD storage cabinet and the tape drive storage cabinet that I showed earlier, and let's show it again here. Yeah, in the right side, as can you see, we have two different storage: the HDD storage, wherein the instruction and the process information are installed, and the database also here is uh, resides here. And then for the backup of all the instruction reside here in the tape storage. So these two is represent as the auxiliary storage of the mainframe. And then we have a virtual storage. Actually, virtual storage is an illusion created through ZOS management of from real storage and uh, auxiliary storage through tables. The running portion of our program are kept in the real storage, and the rest is kept in the auxiliary storage. And range of addressable virtual storage available to the user or program for the operating system is separately divided between real storage and auxiliary storage.